Alright, let's talk about adding and subtracting radicals. We can treat adding and subtracting radicals the same way that we treat combining like terms. For instance, in my first example here, I have 3x minus 7x plus x plus 2y. I have like terms with these three right here that I can combine. I can do 3x minus 7x plus 1x. 3 minus 7 is negative 4, plus 1 is negative 3. So I end up having negative 3x plus 2y. And we can't do anything with this 2y here because it doesn't have the same variable as these x terms do. Adding and subtracting radicals works the same way, except instead of having to have the same variable, they have to have the same radical. So in my second example here, see, this is very similar to the first example. Instead of 3x, I have 3 root 2, negative 7x becomes negative 7 root 2, plus x becomes plus root 2, and then instead of 2y, I just have the square root of 5, something that's different, has a different radical. We can combine all of the terms that have root 2. When I combine these radical terms, the radical doesn't change. The only thing that changes is the coefficient. So I'm going to add 3 and negative 7 and positive 1. 3 plus negative 7 gives me negative 4, plus 1 is negative 3. Root 2, that part doesn't change, plus root 5. The root 5 stays separate because it doesn't have the same radical. So this is the most simplified version of that problem. Let's look at another example. In this example, I have 2 times root 20 minus root 20 plus 3 root 20 minus 2 root 45. Now, even though I see some like radicals here, I have 3 root 20s and then I have a root 45. Even though these look like I can combine them, before I do anything, I want to make sure that all of my radicals are as simplified as possible. So I'm going to simplify the square root of 20 to start. I'm going to find the prime factorization. I know I can do 4 times 5 to make 20, and I know I can do 2 times 2 to make 5. So root 20 becomes 2 times 2 times 5 under the radical. And because I have two 2's, 2 times 2 is 4. I can take the square root of that. The square root of 4 is 2, and I wind up with 2 root 5. I'm also going to do that for the square root of 45. I know I can do 9 times 5 to make 45, and 3 times 3 makes 9. So the square root of 45 becomes the square root of 3 times 3 times 5. Again, because I have this pair here, 3 times 3 is 9. The square root of 9 is 3. 3 root 5. So now, everywhere I see a root 20, I'm going to replace it with 2 root 5. And everywhere I see a root 45, I'm going to replace it with 3 root 5. So 2 root 20 is going to become 2 times 2 root 5. 2 times 2 root 5 is going to give me 4 root 5. 2 times 2 is 4. The root 5 doesn't get multiplied because it's in that radical all by itself. Minus root 20 is 2 root 5. Plus 3 times 2 root 5, that's 6 root 5. Minus, now this is 2 times root 45, so it's going to be 2 times 3 root 5, which is 6 root 5. 2 times 3 gives me 6, and we have root 5. And now I see, after I've simplified everything, I have all like radicals, and I can combine those like terms now. So I can do 4 minus 2 is 2, plus 6 is 8, minus 6 is 2 root 5. So this is our simplest version of this long expression that we started with, 2 root 5. Okay, let's try one more example. First thing I'm going to do once again is simplify all of my radicals. So I can do square root of 27. I know 9 times 3 is 27, and I know 3 times 3 is 9. So the square root of 27 becomes the square root of 3 times 3 times 3. I can take one pair of these 3's. That gives me 9. The square root of 9 is 3. So that gets to come outside of the radical, and I have 3 root 3 from the square root of 27. Now I can do the same thing with 45. You know, we just did this problem, and I know that that's going to give me 3 root 5. And then I have the square root of 20. Wait, I just did this problem too. I know that's going to be 2 root 5. So that saves us a little bit of work that some of these are repeating. And now once again, I'm just going to replace all of the radicals in our original problem with their simplified version. So negative root 27 is going to be negative 3 root 3. 3 root 45, so it's 3 times root 45, but root 45 is 3 root 5. So 3 times 3 gives me 9. I have minus 9 root 5 minus the square root of 20. That's going to be minus 2 root 5. Then I have plus 2 root 45. That's going to be plus 6 root 5 because I have 2 times 3 root 5. 2 times 3 is going to give me 6. And now I can start combining my like radicals. Negative 3 root 3. I actually don't have any other root 3's, so this one is just going to stay. There's nothing to combine that with. And then I have 1, 2, 3 terms that have root 5. So I can combine those. Negative 9 minus 2 is negative 11. Negative 11 plus 6 gives me negative 5 root 5. And because our radicals are as simple as they can get, and there's nothing left to combine, this is our final answer.